Oh yeah. Okay.
Esta también es pública.
Yeah. Hold on. Make it. Hello, everyone. How's everybody over there in cold land in the what is called the polar vortex? We're in the South Pole vortex because over here it's very hot. As you can see, we're a little colored, and that's because I got a suntan, and my dear son here, he got a sunburn. We both got it in Uruguay, someplace.
We caught it. I caught the sunburns.
Anyway, I think we have a pretty good show for you today, and that's we're going to call it philosophy of physics. You know, there are issues that whenever you're dealing with physics, they may not relate directly to physics,
No,
right?
more specific, they won't. They're not physics, so they might not be physics.
Per se.
I mean, it's not even per se. It's not physics. It's the philosophy of physics. So
These are
anything that has to do with physics that is not about objects, that is not about gravity, that is not about magnetism, that's not about light, that's not about
or the
objects.
atom, but
Basically,
it's
the concepts
uh,
that surround the discussion of physics.
right, right. In other words, it's what you have to keep in mind as a background. Things to keep in mind when you're dealing with physics. They pop up in any discussion, in any conversation. And what Ansir has done, he's made a list of these. I pitched in a couple, but I agree with all the rest for sure. We discussed them, and we'd like to share them with you today. So, well, why don't we get started?
This is a list of that I kind of came up with off the top of my head, but it's not really. I wasn't conscious of these issues until we did this Patreon for so long. Because while we were doing this Patreon and doing our podcast, we just ran into these same issues over and over, and or we would kind of get bogged down, or one topic would be very interesting that isn't about physics. It's not that we're trying to explain magnetism or maybe explain a theory of someone else about magnetism, or trying to tear it down, or dissect someone else's theory, our theory. Nothing about that. It's really about the discussion of physics itself.
And they
For
always pop up in some discussion,
Yeah, yeah, yeah.
always come up.
It's like they're always in the background. It's like I told my dad, it's kind of like you can't do physics without philosophy, and obviously you can't do philosophy without physics. It's like they really go. They really it almost doesn't have any sense to separate the two. I mean, it is because obviously the question, whatever question you ask, is either a physics question or a philosophy question, but questions are questions. You kind of have to just answer them.
People sometimes say, well, I don't want to deal with that. That's semantics. It's like, what's that got to do with physics? I want to do electricity or I
That's
want to do atoms. What are you talking to me about all this nonsense?
yeah.
You're doing semantics, you're doing metaphysics, and these are issues that are important, on the one hand, to keep in the background because they always pop up. The other one is that you always go back to these issues one way or another. You'll see them pop up in any discussion, any debate on physics. They
They're
always
really
come up.
philosophy of science.
Yeah, yeah,
But I kind of made the list more specifically for
of
physics, because that's
physics.
just what I had in mind. And it's like 20 things as we
Yeah,
know.
yeah.
It's like
We
so.
here I'm
I
gonna
mean,
divide into three lists, but yeah,
some of the things are obviously more umbrella topics. They cover way more subjects, and some of them are just more specific that you just kind of run into.
Yeah.
I guess we can.
Well, let's go with the first list. I divided them in three parts because it's easier to show on the screen. So here we'll go with the first part of the list, and you'll see what we're talking about here. Okay, number one here.
It's just a simple list.
Yeah, and it's just a brainstorming list. Keep that in mind.
Oh,
But
yeah,
if you look at this, you'll see what yeah, you can. Someone says here natural philosophy. In a way, that's what it used to be called, like four centuries ago, right? But here it goes. Okay.
The first one, for example, know and believe, that's a topic. All of it. So we could probably write a book about those two words.
Yeah, people always ask, how do you know, or how can you
Yeah.
prove, or is that a fact? How can we verify? And or is it what you believe, or is it what you know?
And these are all there's no particular order, obviously.
Right,
I
right,
wouldn't
right.
I wouldn't start with no belief.
Yeah,
I'd probably start with definitions and notions, the second one, but I guess we'll start with know and belief. I mean, I guess we'll just talk a little bit about each one.
yeah, but
The
I
topic
think,
of know and belief
yeah,
and proof.
uh-huh.
One of my least favorite word in the English language would have to be proof,
yeah,
because there is
what
no
is
such
proof?
thing as proof. It's
What does it mean? What does proof mean?
You know what?
To prove. I prove.
yeah.
Who did I prove to? One issue. And what does it mean to prove? Does
Yeah.
it mean I twisted your arm and convinced you? Is that what proof means?
My favorite phrase is, or one of my favorite phrases is proof is persuasion. And when you put it like that, it's like, well, that's not proof. But it is, because when you say it's been proven, you haven't finished the sentence.
It's not
it's
persuasion.
to whom.
Is it convincing?
But it's the same thing. Convincing
Oh.
is just the cousin of persuasion.
Okay.
So, but
Yeah.
when you say it's been proven, you haven't finished the phrase basically, because you have to say to whom. To whom has it been proven?
Yeah, but when they say scientists
Have proven it. Yeah, but to whom? You always have to ask to whom. It's just like the word offensive, or when you say that's offensive, you always have to ask to whom. To whom is that offensive?
Okay, but let's look at a specific
It's a
scenario.
to whom
You had a few months ago, almost a year maybe now, two black holes collided. Right? We all know this because it's knowledge.
No, that's the
Yeah,
topic.
yeah, we're knowledge. It's knowledge, right?
Maybe it is the place to start.
They know that two black holes collided and sent us gravity waves, which were predicted by Einstein's relativity. That was and they got the Nobel Prize for all this, right? So we've proven it. We know they collided. They sent us gravity waves. Not only did they confirm black holes, the existence of black holes with that, but now we've proven gravity waves. Now, what do you think of that? Knowledge.
The problem, I think, with each one of these topics is they're so vast that it might do it a disservice to just give each one like 5 minutes. You really have
Yeah,
to go
okay.
deep.
We're going to be moving on. We just want to
Yeah,
get.
but that's the thing. I want to try to make it as concise as possible.
Okay.
Obviously,
Okay.
we just came up with this list, and we didn't go
Yeah.
very deep into the issue of synthesizing the problem of each one quickly. So we're not crisp on this yet.
Even though, we are kind of improvising here. We're doing a little brainstorming, but we brainstormed the list. He did most of the work.
But
that's what he gets.
But to be
paid
more
those big
specific,
bucks
I
for.
didn't just pull the list out of my ass. It's more. It's just a list of because each one of these topics we've probably had a whole maybe 5 hours dedicated to it. If you aggregate all the time we talked about each one of these in each one of our podcasts,
Right,
if you aggregate it, you'll be like, man, they talked about this for about like 6 to 8 hours.
We've had
And
a
this
lot
is
of this
where-
already in our discussions in the past. Okay, by the way.
But okay, back to know and belief, right?
Uh-huh. Yeah. Okay. So let's go with the second one on the list.
Let me finish real
Yeah,
quick with
okay.
with know and belief.
Uh-huh.
I had a long debate with some friends, and I never talk physics because I know it gets real.
How come you always talk physics?
Yeah,
with me?
with him, yeah. With everyone else, I just black holes, that's cool. Because you don't want to. I don't know. It becomes an ego trip way too fast. Everyone starts questioning each other's intelligence, and it starts one of those things. And I'm a really agreeable guy. I'm just a nice guy for that. And but usually when we talk about it, usually starts with black holes. just flat out. It usually starts with something like, "Oh yeah, black hole something something," and
They've proven
maybe
it.
they ask me, and it's like, and I'll be like, I don't believe in black holes." I mean, you don't believe in black holes. It's that word belief,
Yeah.
the word belief, and the word no. Because I mean, what was it that we ended
Well,
up?
well, it's because they believe that you believe, or don't believe in this case,
Yeah.
but they already know and it's been proven.
That's the thing.
And so, how is
It's
it
like,
that you don't believe when we have proven?
You get put into the same categories of flat earther.
Yeah.
It's
or,
like,
crank.
I mean, the way everyone feels about flat earthers is, we know the Earth is round, and if you deny that, you're dumb. That's just
Yeah,
that's the narrative.
Yeah.
And
You can't deny black holes.
yeah, but when you're talking about knowledge, I mean, the place we always end up is you can't know anything, because when we're talking about know, the notion know, not the definition, because I mean, we tried defining the word know, and if you try to define it scientifically, you cut off too much of what the notion, what we kind of mean with the word know. So you cut off too much of it. So you really can't define it scientifically and catch the whole meaning. It just doesn't work. I mean, you can try and you'll find out it gets really weird. But when you're talking about belief, because we with my friends, I would discuss, and we would be like, for example, the Earth being flat, same topic. Well, my friends would come up with, in the past, we used to think that the world was flat. We, as in the general populace.
Or yeah.
And so I would come at them and be like, well, or my brother in this case said, so we knew that the world was flat,
We knew.
or did we believe?
Right.
And at what point do you know? At what point? Because no is just undeniable. It's kind of like what Bob says. It's what Mother Nature knows. It's what God knows. It's how the universe actually runs its shop. That's no.
That's no.
But since we can never ask God, we can never ask Mother Nature. We're always left with just kind of assumptions, beliefs. We just kind of assume something, and we take that to the logical conclusion, and we match that with other assumptions and the logical conclusions. So we just have a list of explanations for something, and then what you believe, that's a separate issue. That's out of science.
But you know, there's a couple issues there. If we know something, right? How, like a theory, and we say we've proven this theory, we know this for a fact, whatever theory it is, it doesn't really matter. How is it possible that later on we find out, oh, well, it wasn't like you said, it was this other way, right? And so they developed this notion today that all theories are temporary, are placeholders, right? And so people have that idea, and you say, well, hold, you said you know such and such thing. And they say, well, all theories are really temporary. Well, then we don't know them. Because
Yeah.
if you know,
It's-
you'll never modify it ever again. I mean, if God exists and we say we know that God exists, you can't change that later and say, well, we're not sure, we're still investigating. You can't do that. If you know, you know. And if you don't know, please tell me that you
Yeah.
don't know or that you believe. But
It's-
don't call it knowledge.
But then when I came to my friends with the fact that, okay, we don't know anything, right?
Yeah.
Assuming you could just replace all the, anytime you use know with believe, I mean, it makes sense. You could very kind of not easily, but you could replace the word know very quickly with believe. But then when I say, okay, you don't know anything, everything's a belief, they just say, oh, so we're just guessing every day. Oh, I don't know when the water will boil, because I don't know if it's 90 degrees or 180. It's like, we don't know anything. Oh, I guess I'll just jump out of the balcony. What? That's just a belief, Is the
Yeah.
belief in gravity, that kind of thing. And it's just kind
Let's
of
prove it.
gets taken to the ridiculous real quick. But that's, if you really investigate the issue, you'll find that the words know and belief are a very big headache. And the word proof is
They're getting
used
away.
as kind of a muscling tool.
And by the way, as we all know, the word know means justified true belief if we believe Mr. Plato. And that means that if justified true belief, knowledge is just a belief, another form of belief, if you want that, means you're justified in your belief. And so we go back to knowledge equal belief.
Jeez, we're already 15 minutes in. Let's get to the next one.
Okay, let's get to the. We're running behind, folks. So
It's because each one is just such a big topic.
Some good arguments here. I just wanted to comment one. Who was it here? Where was it? Faith is believing in something you know isn't true. Mark Twain. Yeah, correct.
So next we have definitions and notions, or definitions versus notions.
Okay.
And really, the topic of definitions Like you don't even have to talk about notions. The topic of definitions might be the biggest issue in physics ever, because it's just such a huge topic when you talk about definitions. And like Bob says, that's just semantics. People kind of brush it off. They don't
Yeah,
find they
like,
don't seem to see the importance in speaking logically, speaking if this then that, if this then that, and just following logic literally perfectly. Because once you start talking in vague poetries, when you say a word that you haven't completely defined, then you're basically leaving room for error. You're leaving room for misunderstanding.
but my son, who does some programming on the side here, he came up with a solution. We test definitions not by giving it to people like us. We're human. We make errors. We're not trustworthy. So the way you do it is you program it into a computer. Okay, whatever definition you want, I don't care. Okay, and you program it into the computer, and now you test any theory you want using that definition or those definitions if you have a series of them, right?
Yeah, yeah.
And those will be the critical words that the computer will use. And then you let the computer test your definition because the computer is not going to be, malleable. It's just going to use the term that you fed into it,
Exactly.
literally.
But-
It won't
but-
allow you to, go off on a tangent.
Because the difference with computers and humans is with a computer you have to program every single
Yeah.
definition. While with a human, if I say cat, we all kind of understand wink, wink, blink, blink. I mean, that one's an easy one because we all can understand a cat, but we all have a different cat in our head.
No, I like a better one, like the word particle. A better word is
Yeah,
particle.
particle.
I mean, if you say, well, particle, and you
Everyone-
say, what is a particle? Well, it can only be a corpuscle, or it can be a field, or it can be a wave of some kind, and you got to tell the computer what are you going to use? And you can't say, well, I'm going to call it a particle. Okay, but what do you mean by particle? Well, it's really a wave. You see, it's a wave of what? You got to tell all this thing, and then the computer can use it consistently. But if you program it in there with a wishy-washy kind of definition, you're going to run into a lot of trouble. If you say, for example, an object. What is an object? Well, an object is that which has shape. Fine, no problem. But if you say an object is that which has mass, right? And now you determine that a black hole has mass, and you say, okay, a black hole is an object. But at the same time, a black hole doesn't have shape. It's zero volume, And so now you got to select. Are you going to use this definition or are you going to use that one? And I'm sure that if you do not define your terms very specifically to a computer, at some point it's going to spit out and say, you're an idiot.
Yeah. I mean, the other word
It
here
does not compute.
The other word here was notions, and we use that word to kind of compare against definition, because
Yeah.
what we mean by a definition is rigorous.
Scientific.
What was the word? Conditions.
Yeah.
It's a list of conditions by which you use this word. Like if I define cat as that which has 4 legs, a head, a tail, and says meow,
Assuming.
only things that follow those conditions can I call a cat? Like perfect logic programming. A notion, on the other hand, is a definition before it's a definition. It's what we mean by a word before you define. So you haven't defined it yet, but it's just what we mean by, for example, the word no. What do we mean by no?
Yeah.
In what instances do we use the word? I know that Napoleon fought at Waterloo. That's one version of no. I know that if I boil water or heat water up to 100 degrees, it will boil. That's a different type of no, because it's pattern recognition, not historical.
You know God. The
Yeah,
existence of
yeah.
God,
I
yeah.
know the something exists. Now it's a question. It's binary. It's is it or isn't it, and you can't really investigate. It's just an assumption that you either take or don't take. So there's many different versions of no. So we have the notion of no is the ordinary definition, I guess.
Of
you
the
could say.
dictionary.
Yeah, kind of the dictionary.
Yeah.
What do we mean when we say this word? But it's not set in stone. It's not something you can use.
scientific.
Yeah, it's not something you can use perfectly consistently.
Yeah.
At some point, you'll probably break down and be like, "Well, hold on. Now you're kind of not using the word how you defined it. So now you're kind of cheating." And
Yeah, the other issue is that we have this idea here, us too, right? That what we find in ordinary dictionaries are not definitions.
they're not sufficient for science.
They're notions. They're vague notions. We don't have to know exactly what the word love means. it's close enough.
Because
Love, whatever love
when
means
you look
to you.
in the dictionary, you get so many synonyms and circular definitions.
And nobody
Whereas
cares.
this means that means this. So you kind of go in a loop.
Yeah.
Someone kind of just has to someone has to show you it, or you know what I mean, that kind of thing. It's
Yeah.
very vague. It's very vague.
And it works for poetry, but not for science.
And the way defining works is you take the notion of something. I guess I'll make this circle. This is the notion of the word love. Everything that's in this bubble has to do with the topic of love. But then when you want to define it for the physics, what you do is you kind of take a cookie cutter of definition, and because you're never going to define something and get the whole thing. Because everyone has different notions of different words. He has a different notion for love. I mean, in when you talk about specifics, if I wrote a list of everything that had to do with love, and Pops wrote a list of everything that had to do with love, there would be some overlap.
Mm-hmm.
And with the definition, you kind of want to just catch the overlap of everyone in the room, so we all know kind of something like that. But it's very tricky when you try defining words.
Besides, you got to separate agreement between, on the one hand, we all sign the contract and we say, okay, let's all agree to this definition.
Yeah.
That's one issue. And another one is when you're giving a presentation, you say, let me tell you what I mean by this word and how I'm going to use it in my
The
theory.
presentation issues, it kind of cuts through a lot of this, because you just define a word the way you're going to use it in the presentation.
Right.
I'm going to define this word as such. So every time I utter this phoneme, this sound, this is exactly what I mean by that. So there's no confusion.
Okay,
It's really just to streamline the process of conveying information.
let's move on because we got a lot of material to cover here in a way. So we're moving on here.
Rules of physics. How does science debate presentation discussion? Yeah, it's kind of oh man, this is a big one.
How to debate? You mean in present?
Yeah, how to do a science debate, how to do a science presentation, how to do a scientific discussion.
Okay, what's the issue there? I
rules
can't remember.
The rules of physics.
Uh-huh.
It's when you talked about science, and then that branches off into physics and philosophy, and you were trying to kind of separate the two, so that what was it in physics? It was like it deals with objects, and philosophy deals with concepts. In physics, it deals with I don't know if you still have that picture, but it's basically
Yeah, I've got that separation between physics and philosophy as two branches of science, and then within each one of those, you have all these other. What you going to look at?
because how to do a science debate, presentation, or discussion. In a nutshell, it's what are when two people are talking, right? If they're both talking about the weather, oh man, sure it's hot outside. You can tell they're not having a scientific discussion, because there are certain guidelines or rules, certain conditions that must be met to kind of point to something and be like, they're having a scientific discussion. Mm-hmm. So what is a scientific discussion? What are the conditions, or what are the rules that
Precondition?
Yeah, preconditions. When you see
prerequisites.
When you see a kid asking his grandpa, "Hey, how does a magnet work?" and the grandpa tries to explain, "Well, a magnet works because angels come from the sky and they push the magnet from both
Together.
ends." It's kind of physics, but it kind of isn't. You can kind of like, okay, he's obviously trying to explain something to this kid. So this kid really wants to know how the universe works, or how this part of the universe works. Just this phenomenon that is obviously repeatable, and it's a thing you kind of have to contend with. It's part of reality that you can't see, so you have to explain it. It's not like you see a dude pushing a ball and you can, that doesn't need explanation.
Are we saying that we're not going to allow certain things to be introduced into the discussion?
Yeah, it's something like that.
Because it's supernatural, or why?
Not because it's supernatural, it's because it's illogical or irrational. I
agree.
It's almost like, what are the things that you have to offhand throw out? When someone says there's nothing in between two objects, but they come together. Or there's no, if you have two What's the
Yeah, well, the one we discussed this week, where the gravity is explained by the expansion of everything in the universe. So what you're having is, it's not that one object approaches another; it's that they all become bigger and the distance between them decreases.
Yeah, no, but that was
It's
still
like,
that was still physics
is
because
it?
he's
I
trying
don't
to
know.
explain
Not
it.
to me.
But what was the physics? It's one thing you can't do in a physics debate is walk up and punch the other guy. Let's start there.
Oh, I like that.
You can't. You
I
can't.
use
There's
baseball
certain.
bat.
Yeah, there are certain things you can't do and still call it a debate or a scientific debate. If someone starts just denying everything and doesn't want to listen to reason, or just starts trying to push his faith onto people, it's like he's kind of.
That I
It's like
agree.
a boxing match where the guy isn't doing boxing. He's kicking. He's grabbing.
So he's not following the rules.
Yeah, he's not following the rules. It's like
Okay.
it kind of comes down to the purpose of physics. If the purpose of physics is to explain real phenomenon that we see, that we can't see the mechanism, we can't see it because it's invisible, but we still have to kind of explain, okay, how could this work? If we could zoom in and make all the parts visible, what does this look like? And that's kind of what we all want to know. If you see two things click together, two pieces of metal, you don't just say, oh yeah, that's how it is. You kind of want to know, if you do want to know.
You want to know the mechanism.
Yeah, what's the mechanism? How does this work?
Yeah.
And if you just say
Magic.
north attracts south, you haven't really answered the question. You haven't really done physics.
And again, it's got to do a little bit with introducing magic or unjustifiable mechanisms. Like, black hole attracts, supposedly, right? Attracts another star, and the star rolls around the black hole, and it loses gaseous matter from its skin to the black hole. And someone says, well, how does it do that? And the guy says, well, it does it through mass. Mass does it because because the black hole is a very massive object. Fine, you haven't explained the mechanism of how mass does that to that star. That's the issue. The issue, you have not explained it. All you've done is describe that, when you have a big mass in the center, another one's going to roll around. That's all you've done. You haven't told me the mechanism of how that great mass in the center pulls on a star very far away. That's the issue. So that's not science in a sense, because the guy has not explained it.
Mm-hmm.
And so you have to have some kind of ground rules, like a football game or like boxing or whatever.
No,
You need to have ground rules.
I like Bob's came to me with what was the guy who said, what else could it be? What a black hole? That wasn't physics.
Yeah,
Tell him the situation.
Yeah, we had there's a paper. I can't remember the guy's name. Grenzel, I think is his name. Grenzel. He's a German astrophysicist, and he's kind of like an armchair guy. He goes into his office, looks at the stars or the pictures of the stars that people show him, and the guy then says, "Okay, what we noticed that here's this little star and it's moving around something, and there's nothing there." And so the guy says, it's a black hole. What else could it be? That's how they proved it.
Yeah,
Going back to number one, and they proved it by saying, what else could it be?
So it's like,
that's the proof for black holes. What else could it be? Okay, so let's move on along. Let's see if we can get through all of them today.
Oh, the authority problem. That's a big one.
Yeah, it's believe the wiser man. Is that what it is?
Religion of physics, indoctrination, cults. Well, really, the authority problem is simple. But it's a problem. When you have a stomach ache, you go to the doctor because he knows more about doctoring than you. He knows more about how the body works. When you have a plumbing problem, you get the plumber. And when you have a problem of God, you go to the priest. You go to the person who knows.
Probably.
And with physics, well, the person who deals with these issues of celestial objects and the very micron nano level, very small, is a physicist. So when you have a question of that nature, you go to a physicist. So you have to believe what the physicist tells you. Kind of like the doctor. When the doctor says, oh, you have stomach cancer, you don't question him and go, what do you mean? I don't have stomach cancer. Go to hell. I mean, you might get a second opinion to make sure that two people got the same thing, but you still have the problem of believing whoever you go to.
Because you trust the expert.
Yeah, and the same problem applies to physics, where they can kind of say anything. See, the difference with physics and a doctor or a plumber is doctors and plumbers, you can see the results. You can see if you go to the doctor, he says you have stomach cancer. They give you stomach cancer pills or do whatever treatment, and it doesn't work. Then either he didn't know, or I mean, a lot of things could go wrong. Let's take a plumber, more simple. If a plumber says, "Oh yeah, you have this plumbing problem," he goes to fix it and he goes away, and then in 2 weeks you have the same problem again. He didn't do his job. You can tell that he didn't get the results that he was paid to do. And with a physicist, the problem is you go to him with a question, and he can kind of say anything. He has no checks and balances because there's nothing you can take to the bank. There's no real thing that you can do to see if he's right or wrong. If he says, "Oh yeah," I mean, if they go to the extreme and say a fairy moved the planet, then you'll be like, okay, this guy's probably crazy. But if he says
Black
a
hole.
black hole, or if he pulls out a fancy word, then it's like, oh man, that's really smart
That's
stuff.
deep.
Yeah, that's deep. That's smart stuff, and you just kind of have to shrug it off, even if you didn't understand it. You still have to just be like, oh, this guy knows and I don't, and I wish I knew more about science to kind of understand this. And it kind of just becomes a bummer with scientists and in the physics department, you know.
Yeah, and that's a problem because and I think it's part of the culture for everyone to say, "Oh, I got a PhD from Cambridge University," right? And so people say, "Whoa, oh man,
This guy knows.
yeah, it's like now anything he says is gonna be law now." It's like, yeah, black holes move stars around. The guy gonna say, "Oh my God, yeah,
It
it's gotta be
kinda-
like that." I don't understand all that, but I guess all you scientists who do all that math, you guys must know. And so you're not accepting it on the basis of rationality. You're not saying, "Okay, the guy said something very interesting that I can understand." You guys, it's the opposite. You say, "Well, I don't understand anything, but man, that blows my mind. That's deep." It's
It
the
does.
guy hasn't given you any explanation of anything. Someone here said just a minute ago, demonstration is more important than explanation. No, demonstration means they convinced you. They fooled you. In science, we don't demonstrate.
Oh, you can.
We don't convince. We don't persuade. In science, we only explain objectively so that you understand the mechanism. Once you understand, you reach your own conclusion.
I mean,
we don't care.
You have magicians whose whole job is to demonstrate things that
Right.
are there.
And you still don't understand the mechanism. I mean, if a guy cuts the lady in half, he demonstrated, but he hasn't explained yet how he did the trick. Science is about how he did the trick, now not watching him cut the lady in half, which is just a demonstration.
Logical, rational, imaginable. Programming, computer must understand. Oh yeah, we already talked about the computer having to understand your physics.
Yeah.
Logical, rational, imaginable. Yeah, we talk about. I mean, the channel is kind of called Rational Science. Logical, rational, imaginable. When we're trying to get to the bottom of the word rational, and what's the difference between rational and logical and things like that, or understanding also kind of fell into this category. We summarized it with, to explain something to someone else, you have to make a movie of your theory, at least in physics. If you want to explain what moved the curtain, a breeze comes in, moves the curtain. To explain that, you draw a picture of the curtain, and then you make visible the invisible. That's the job of the explainer, to make the other guy understand. You draw little balls everywhere where the air is, and then you just kind of explain with like a Newton's cradle kind of force. This ball pushing that ball, this ball pushing that ball. It's like all the balls push each other, and then it eventually hits the curtain and pushes the curtain.
Right, away.
And with that, you kind of
explain the mechanism.
And by explain more specifically, the other person understands at least a version. One way of explaining how the curtain moved.
The other one is the spirits.
Yeah, the other one is the spirits, but that's a different issue. Yeah, making the movie in your head of what's going on. I mean, when someone tells you how a car works or wants to tell you how a car works, you kind of have to make the whole engine in your head. You go, or at least piece by piece. Okay, then this fluid goes into here, and then it gets pressurized, combustion pushes these two apart, and you have to make a movie. I mean, it's kind of impossible to do physics with just words. You almost always have to end up in the visual, the pictures,
Yeah.
or
Physics is done with
Yeah.
movies, with pictures.
it's really weird.
Yeah. Okay, let's go with the next one. Again, we got some material to cover.
Explaining and understanding. Yeah, parts made visible. Can you repeat it in your own words? Yeah.
Okay, yeah, that's
It's
also
that
good.
same it's that same topic where
Yeah.
what the if the purpose of physics at least is to explain or get your movie into the other person's head, whether he accepts it or not is a separate issue, but that he at least sees what explanation, what shapes do what movements to explain which phenomenon, so the guy can be like, okay, that's one possibility. I'll put that in the back burner. That could be one explanation for gravity, for example. Then the guy has a list to choose what he believes, or I mean, I guess you can't really choose your beliefs, but you'll end up believing one of the things in the brainstorming section of explanations for a phenomenon. For example, how does gravity work? If someone comes to you, how does gravity work? Okay, what are the possible explanations? You got those. You got the rope. You got
Particles.
this expansion of every object. You got the flat Earth that says the Earth is going up at it's accelerating at 9.81 up, whatever that is. You have particles. A ball
Waves.
hits your face and you go forward. It hits you with negative
And
force.
the other one is the particles push you
Particles.
from the outside. You remove the
So
particles
you
between
get this list of explanations, and
You got to choose which one.
yeah. But choosing which one, that's the belief part. But
Yeah.
if you want to explain, like if someone comes and has a new theory of gravity, for example, he has to basically make a movie of his theory
Right.
so that you can at least visualize it, so you can consider it. You can't consider something you don't understand. That's the bottom line.
Right. Like space-time is space-time warpage. Show me. Don't
Yeah.
talk. Don't talk. Don't say a word. Just show me the mechanism on the screen so I know how an object is attracted to another. Anyway, we had a call here. Anyways, what we're saying, you got to illustrate. Physics is about illustrating something.
The president of the universe is calling us.
God is calling us. Oh, okay, we must be in trouble already. Okay, let's go with the next one.
Explain versus describe. Telling what needs to be understood versus how much do you have to describe until it is understood.
Okay.
Explain versus describe. That's another big one, man. It's because they're so nuanced. That's the problem. It's really hard to talk about it real quick.
And that is a big one in this sense. It's a big one in the sense that if for the last 400 years, what they've been doing is describing. That's all they've been doing. They've
In
never,
physics.
yeah, because they haven't explained a single thing in a rational way. So it's called descriptions. What Newton did was description. What Einstein did was description.
For
what
example,
Hawking did was description.
For example,
Only.
when someone says, asks, how does magnetism work?
Yeah.
And the guy says, north
Attracts south. Yeah.
Well, yeah, we all saw that. I mean, that's
Well, you
that's
label
not
that.
that's not the question. It's like, yeah, okay, yeah, that's just the description of what's going on. Yeah, and another description is you have these iron filings, and you can see the shape that magnetism takes. That's just a description of the properties of magnetism, but you haven't explained the mechanism. You haven't said why do they have that shape and not this shape or that shape or whatever other shape.
Yeah.
And why does north attract south? What is north and south?
Yeah, you could say red attracts blue.
Yeah.
If you paint the magnet blue and red, like half and half, you say, well, for some reason, red attracts blue, and when I put blue or red against red, it pushes each other away. What have you explained? You have not explained anything. All you're saying is that somehow every time you put red against blue, it attracts it. That's a description. You have to explain the mechanism, and not to believe it, not to demonstrate. It's to so that you understand the mechanism. You need to understand the mechanism.
It's the invisible visible. It's you can
Right.
you can basically fill in the gaps of what Mother Nature did and what Mother Nature made hidden. You can fill in the gaps and be, if the guy cuts the magician cuts the lady in half, you can kind of fill in the gaps. Oh yeah, well her body is under the saw. So you can fill in the gaps of what's missing, what's being hidden,
Right.
to make it magic. basically.
To make it to fool you, yeah.
But this topic kind of goes into one of the other topics that I wrote down. Now that I think about it, which is
maybe it's in the next one.
Uh-huh.
Let's see. We're gonna go with the second group here.
Well, let me look for it real quick because it
Okay.
has to do with that. No, none of these. Oh yeah, it's that one. Layers of knowledge, exactly. Layers of knowledge. How does the remote control work? Press buttons, electricity. Basically, layers of knowledge topic is if someone asks how does the remote control work, you say, oh, you press this button, turns the TV on. This button gets the channel. This button gets the volume. But then,
It is an explanation.
Yeah,
but very, very basic.
And then
Press
the guy
the
asks,
button.
well, yeah, but how does it work? Like, what are the physical mechanisms that
Right.
make the thing work? And then, okay, well,
Yeah,
when
you
you
go
push
deeper.
when you push this, yeah, it's the layer under that is okay. Well, you push the one button, that button hits a transistor, which shoots an electrical current over to this thing, which it reads as a 1, sends that through infrared or radio waves to the TV, and the TV translates that into a channel.
Yeah.
That's another layer. And then the guy asks, well, what is electricity? What do you mean by electricity? Now you have to go deeper. Okay, well, electricity is this row of atoms that spin and do that. And then you go even deeper. What's an atom? Lower, lower,
Right.
lower, lower.
And we had that situation with this fellow the other day on that one, where he said, we have a beam of electrons, because that's what he considered electricity. And so then the question that I asked him is, tell me what your atom looks like. I mean, are you saying that this little bead called the electron goes around the atom, around the nucleus? And that's where he starts running into trouble, because now he's got to justify how that electron is tied to the nucleus. And what's he going to put in there? Well, again, that's where he ran into trouble, in that space between the nucleus and the electron. He can't draw his atom to begin with, though he can't talk about a beam of electrons if he cannot draw his atom. He's got to start there at the atom.
And it goes down to the previous topic of explain versus describe, where you can describe, you have the proton here and the electron goes around here.
Yeah.
That's a description. Okay, I can draw that, but then you have to say, okay,
Right.
well, what
Explain.
the explanation becomes, okay, or the deeper question of layer of knowledge is, okay, why doesn't this electron fly off, or
fall to
since
the
it's
center?
negative and positive, as you have
Just stated.
stated
yeah.
that they attract each other, why doesn't it go to the center?
Right.
There are certain questions that have to be answered
in
or
order to
contended with.
understand the foundation.
In order to to explain, because once you have the foundation, then from there up
you
it
can
all makes
construct.
sense. Yeah.
You can construct. But if you cannot explain your atom, if you cannot explain how your electron bead does not fall, because it's negative, fall to the positive nucleus, or how it manages to avoid flying away by itself spontaneously, if you cannot explain that, you got to work on your atom before you come to the conference. That's the issue.
That layers of knowledge and explain versus describe. Explain versus describe is tricky because, again, if someone says, why doesn't the moon fly off?
Yeah.
What keeps it tethered? I mean, you can already tell us the rope. What keeps it in the orbit of Earth?
Yeah.
Assuming that's what's going on.
Yeah.
You always got to be scientific and robotic with this stuff. Assuming the Earth goes, the moon goes around the Earth. Why does it do that? Why doesn't it fly off? Why doesn't it come crashing towards us?
Yeah,
and then they say,
look at the
if
mechanism.
someone just comes and says, "Oh yeah, gravity keeps
Or
it there,"
right, gravity or
that's a
mass
description.
or mass.
It's like a surface layer description. Yeah, or you say mass. It's like, well, that doesn't really. I can't make a movie of
Mass.
why it doesn't fly away.
Right. If you take Newton's equation, very simple, most people know it, mass times mass divided by distance squared. Okay, it's a description of why the moon doesn't fly away, but it's only a description because all you have is mass, and distance.
Well,
But then you say, what keeps the moon tethered or prevents it from flying away or falling to the earth? Now you need to put something in there, some physical object that you got to make visible to understand the mechanism.
And for example, real quick, in that same case, if you say particles, gravitons, these little balls fly off out of the Earth and hit the moon and pull it towards it, well, how do these balls follow the moon? And other questions come up. And then you have to address those, and it's like until every single hull of this ship is covered, it is not floating.
Good. I like that, yeah. It sinks, right?
Yeah.
Okay, let's go with the next one.
how you say something versus what is being said. Cult pastors, gurus, Carl Sagan, Neil Tyson, and Bill Gates. Yeah.
Uh-huh.
How you say something versus what is being said. This is really the biggest issue for Pops, for my dad, because he has a very explosive, very kind of vindictive. I gotta get him.
Baseball bat. It's called baseball bat therapy.
Kind of macho physics, where it's like, okay, me against you. It's like a war. It's like a battle, and it's fun for him. He goes into the boxing match. Okay, let's beat each other up until we figure this out. Bap, 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 bap. You're wrong about that, you idiot. Bap, bap. And it's like it's a sport for him. But how you say something, if the purpose of physics is to get the other person to understand your theory, not believe, just understand it, right?
Then
some people don't understand physics that way.
The rationality of physics.
Because some people are need more understanding.
More
some
baseball bat.
less baseball bat. Where they get it's like the when you call them an idiot or something, it kind of throws them off. It's like it blinds, it gets in the way of their understanding of physics. So it's like
it becomes it becomes personal. You muddy the water.
Exactly.
But see, I don't call anyone an idiot. I'm just treating them with the respect that they deserve.
But really, that's not even what this topic was about. It's
it wasn't?
More. No. It's how you say something versus what is being said. How you did I say? No.
It was in the third one. I think we jumped over to the third one.
Yeah, we're jumping around here.
How you
say something versus what is being said.
Yeah, ad hominem.
It's really about how something is said. You can't just give someone else information like a robot. You can't. For someone else to understand something, you really have to work with them. It's weird where to get, like, if you're trying to get a kid to understand something.
Okay, let's look at that.
What are the techniques or methods or ways of speaking that you use to convey this as efficiently as possible? Yeah, but it's a whole art. It's a whole art form. That's why they have debate clubs and things like that, because there are certain ways. If while I'm doing this, while I'm trying to convey this, I'm moving around and I'm waving my arms or doing whatever, shaking my head. It's like you get distracted. Okay, it just gets in the way of, or if I start talking in poetry, in tongues or in poetry,
speaking in tongues,
it's like I'm just making it difficult for people to understand it. You have to make it as easy to understand as possible, and it's a real art because, besides the fact that we all understand different ways and we all have different personalities and such, it's very hard just to convey information from one rational person to another.
And I think part of it is what Einstein and other people would say in different ways. Many of have said this throughout the history of mathematical physics, is that if you can't explain it to a 10-year-old, if you can't explain it to a barmaid, et cetera, then you don't know it well enough. That means you really...
Well, that's another issue.
And okay, but it also ties in with the fact that the best way to explain a mechanism is through a movie. If you show the movie, people watch the movie, they should understand the mechanism you're proposing for gravity, for light, for magnetism, for electricity, for the workings of the atom. Unless you show that movie, people will not understand. You can't just talk in the abstract mode, say, well, mass and energy and force and time. They'll never understand. If you want them to understand, show them the movie.
Ad hominem, cult of personality. I like this guy, I like this. Yeah, that also convolutes. Really, a lot of these issues are things that get in the way of science or get in the way of physics.
You should keep it. Again, these are things that are in the background.
Ad hominem or this cult of personality thing is like, one thing that I wrote there that I didn't send you is the phrase, even a scumbag can tell the truth.
Scumbag can tell.
Even a scumbag can tell the truth. If you got a guy jerking off and he's like, but he says something that's true, the truth is kind of devoid from the speaker, where even the most holy person can lie in the sense, or even a scumbag can tell the truth, where you have to listen to what's being said and not who's saying it.
Right.
And that's really hard to do because obviously some people you have respect for, like sometimes I'll be listening to something and I'll let something slide. You listen to Carl Sagan for God knows how long.
Yeah.
My dad was an avid listener of Carl Sagan, watcher. He loved Carl
Don't
Sagan.
embarrass me.
Yeah, because he's looking more at the guy.
Right.
He likes the story. He likes this
The
whole
teacher.
It's like a show, and
It is.
I mean, many times when I'm watching Neil deGrasse Tyson, I really like the guy, and I like how he talks, and I like his personality. But when I listen to what he's saying, it's really hard to listen to because there's just so many logical fallacies or assumptions that are being made that just aren't reality, and it's hard to listen to. I mean, many physicists are like that.
Yeah. See, you concentrate on the personality and not what's coming out of
Again,
that.
also the authority issue comes into play here, where you don't listen to what he's saying. You're listening to him because he has authority. Everyone's looking at that guy. Oh, looks like this guy's important. This guy knows. So whatever he says, that's what we're taking.
Or like you said, he's well dressed versus the bum, with all the fleas going around. You don't listen to that guy because you say, what can he possibly know?
Can he possibly? And
Right.
it's a tool that we've used to kind of survive. It's a very useful tool. Obviously, my mom has a famous saying: "They treat you how they see you." Because obviously, if you see a guy who's kind of shaking and he's got a hoodie and stuff, you kind of stay away from that guy because he might stab you, that kind of thing. But he might be a millionaire for all you know. He might just be a normal guy and having a good day.
Okay, let's continue on with this. Let's see if we can cover most of them at
Man,
least.
there's so many.
Hope peddling.
Oh, geez, hope peddling. We can populate other planets. How cool is that? Hope peddling is another thing that convolutes science or makes it difficult. When you are more interested in the dream or what science can accomplish, regardless if it's,
True or not,
true or not, but
or
that's
possible,
also a matter of belief.
Possible
Yeah,
or
but
not.
possible or not is kind of a matter of belief. Where it's saying, oh, I think it's possible. Where someone says, oh, we're going to populate the galaxy. We're going to populate the universe. We're going to be, what do they call it? Tier 3?
Yeah, they've got all these different levels, level
Because
1, level 2, level 3, 4.
It's a nice idea to, when people watch Star Trek, it's awesome. People go, oh man, that'd be so cool if that were true. So let's make it true. And that works. I mean, that's really useful for technology, because if you think it's true, you're gonna try everything that's possible to make it true, to find out if it's true. I guess that's the right way of, like, for example, flight. If we wanted to fly, so we tried everything until we got it right.
Yeah.
So you have this dream, and okay, I mean, you kind of just say, okay, we're gonna fly, regardless of if it's possible in Mother Nature.
You're gonna give it a- you're gonna
okay, let's try this. Let's try
research it.
that.
You're
Let's
gonna
try that.
research
So you
it.
just kind of get it in your head that it's possible. It's possible. So we're just gonna keep going until we do it.
Right.
But then it hit. That was another topic. What's possible? Wait, what's the?
Yeah, I think it was there also.
Yeah.
Right underneath it.
But yeah, let's stick with hope.
Yeah.
But was it in that one? Possible? No.
I think it's the next one, the third one. Oh, you forgot it. I don't think you put it in
No,
there.
I did.
You did?
Wow.
Yeah,
Yeah, no.
theory says-
Okay, maybe I didn't put it in here.
Yeah, maybe not, but
But yeah, hope peddling is a problem because
it
if
makes
you-
the
if-
impossible possible.
no, yeah, but I mean, you can't know what's impossible or possible. The problem is when you're looking more at what use you can pull out of science more
Than the
than
theory.
just science. How do things work? What's the best way to explain things?
Yeah.
And if you say
Well, I have-
time is a dimension that you can
Go through.
move or go through, then it's like, oh, that opens the possibility. Now we have time travel. That'd be so cool. So I'm gonna go with that theory because that one's less depressing.
Or you're right, it's the one that gives you
It
hope.
opens more doors.
Yeah. Well, we have a case of traveling faster than light. You're a tachyon, right? You travel faster than light, and not only do you travel faster than light, but you can go through a wormhole that gives you a shortcut to another galaxy, another star, another universe, whatever, right? And so now it gives you hope. It gives you false hope, a false sense of security, essentially, because now you can say, oh, look, science has discovered faster than light. Maybe I can travel faster than light. Science has discovered the black hole, which is an entrance to a wormhole, and that's a connection to a bridge to another universe. That means I can do that too. And now all of a sudden, in your living room, if you say, well, if science has proven this and science has proven that, means in the future I can imagine me being in another universe. and that goes also by traveling faster than light and being young again, or younger, or meeting yourself in the future, in the past again. And so, if all these things become true, don't know what
Don't
possible.
yeah, it's the 1, 2,
Oh, there it
3,
is,
4.
the
It's
fourth,
the
the
fourth
fourth one
one.
down.
Don't know what is possible, impossible.
Yeah.
In parentheses, I had Jules Verne, because he wrote a lot of books of what he considered impossible.
Right.
But then we made many of them possible. We haven't gotten to the core of the Earth, but many people might suspect, it's possible. We just haven't given it enough brain.
I like the banana
Flight
dimension.
and moon landing, those are things where people said it was impossible, but it turned out to be possible. Then we have teleportation, time travel, which are kind of in this gray zone where people aren't sure if they're possible or not possible. But then there's one banana dimension that I invented in one of the podcasts because
Yeah,
I had to just come up with something that is obviously impossible.
The
just
banana
to have an
dimension.
extreme. Okay, is the banana dimension real? Is that a place we can get to? No, because I just pulled it out of my ass. Obviously, that place doesn't exist. But so we needed that extreme just so that people can say, okay, at least we have something that is. The question kind of boils down to, first of all, are there things that are impossible? Because some people say that nothing is impossible, and you just go to the next person because that person is too far gone.
And again, traveling faster than light, and through wormholes, which, if you believe in them, you're going to say, I can travel through a wormhole at the speed of light or faster than light and arrive anywhere in the universe, wherever I want, through this highway at the velocity that is tolerated by the laws of physics. You can say all that. And if you believe, then you're given false hope. You consider the impossible as possible. And that's one of the problems that we have also, that's why I'm saying, if you can illustrate your theory, then at least we can determine whether it's possible or not. But if you use just words and say, look, I'm going to do time travel and see myself in the past and all this kind of stuff, what are we talking about? I mean, is that science? Is this part of the foundations of science? Okay.
Science versus technology. Hey, there we
another
go.
one.
Science versus technology is a very big topic.
Yeah.
Because
people confuse them.
Science is about explaining, and technology is about use.
Developing gadgets.
And developing gadgets. The golden rule of technology is trial and error. Do this, see if that works. Didn't work. Try this, see if that works. You just keep tinkering. You try, fail, try, fail, try, fail, try, fail, try, fail, until you get the result you want, like the light bulb.
Yeah,
the guy made 1,000 ways.
But no, who was it? Edison. Thomas Edison said, "I have not failed. I've found 10,000 ways that don't work."
And that's technology.
So he never knew what electricity was.
You don't have to know
nature of electricity.
You don't have to know what electricity is
Right.
or how it works in the nitty gritty. In the
I don't need to know what magnetism is or what a magnetic field is in order to pick up pins with a magnet. That's technology, picking up pins.
The use.
Right, the use. But to say that science is technology, no, they're two separate things. One has nothing to do with the other.
But it's not that one has nothing to do with the other. It's kind of like that. But the problem is with technology, when you do trial and error, you have to do trial and error within the realm of what we know, quote unquote, because the Neanderthal can't do trial and error because there's a huge progress of technology where you build on what the guy did before you build. Try within the realm of your understanding, but understanding is kind of in the science area. It's because the layers of knowledge. Oh man, this goes deep. It's kind of goes back to the layers of knowledge thing, where explaining that the light turns on when you flip the switch. That's also science, but very superficial.
Right. How do you turn the light on? You press the button.
So you explained how it works, but at a very superficial level.
Right.
And that's kind of technology works on the superficial level, where you just have to know enough to get a use out of it.
Right.
You just have to know enough to turn the light on or to do something with this light. Maybe you put the light in a series of lights, and now you have a screen. So now you have a different piece of technology. You're basically just building on past technologies, on past trial and errors. But science is taking one of those and going a level deeper in the useless department. We have no use for this, but let's just try to explain it anyway. How could we explain light if we had to, because we haven't. I mean, there might be a use for explaining it. Like we might learn something. in
Well,
that
one thing
sense,
is
but-
to use a laser and say, look, how do you turn the light on? Yeah, I press the button and here's the light, right? Okay, no problem. But you have not explained what the source of light is or how that little gadget works. You know, one thing is technology, the other one is the explanation, which is the science part. And never, or one's got really nothing to do with the other. One has to do with
We already
explanations.
hit the 1 hour mark.
Yeah.
I figured this would be hard.
Yeah.
We might go into overtime.
Yeah,
on
we'll
this one.
go in overtime here.
Um,
Democracy, go with
Oh,
democracy.
democracy in science. The question is, how many people does it take to make something true?
I like that one.
Yeah, that's another thing that convolutes. I mean, that one has.
It has to do with proof. I mean,
No, hold on,
do we
hold on. It has to do with assumptions, really.
Uh-huh.
It's what we accept as assumptions.
Does it?
Yeah, because assumptions is kind of in that realm of belief. That's another topic that I should
Yeah,
write
yeah.
down. The relationship between assumptions and belief, because you
Uh-huh.
only assume things that are within the realm of belief. You don't really consider things that have nothing to do with what you really believe in. And with the democracy issue, we only consider things in science. Like if someone comes to a science debate, you can only really talk about things that we've all kind of it's all within the realm of possibilities. But within the realm of possibilities is the show of hands.
Right. Yeah, in
So-
other words, I mean,
Oh, man,
and no, it's also
it's
for
really
theories. I
complicated.
mean, once you get into a theory, right? The question is, do we prove it by raising our hands and say, oh, 51% voted in favor, 49 against, so we're going to call it a proof now because 51% believe in that theory?
And the replicable.
That's why proof and demonstration have nothing to do with science. It's religious people who talk about proof and demonstrating. In science, we explain objectively so that you understand the
Yeah, the
mechanism.
scientific consensus, like global warming.
Yeah.
There's a lot of scientists that are against global warming,
And
but
and-
not as many as for.
Yeah,
So
okay.
We
so
go with the four guys.
we raise our hands and say, no, what do you mean for?
For global warming.
Oh,
There are people
for
for global
oh,
warming.
okay. I thought you
and
said there were four sides.
Yeah, there's four people
against.
and it's not saying that I don't believe in global warming. It's just showing the issue. Where I mean, that could also be a case of just por las dudas,
Yeah.
just in case.
Yeah.
Let's act as if it does exist, just to stay on the safe side. Like if hell does exist,
You better believe in God.
Yeah, I'll try to be good just in case. It might be a case of that, but a lot of what is pushed into the media is a show of hands.
Yeah.
Or
Who wins the tug of war?
consensus. Yeah, it's consensus
Yeah.
where everyone says, okay,
I
Our-
mean,
our black-
irrespective of whether global
Yeah.
warming is happening or not, or
Yeah,
whether
yeah.
you believe in it or not, the question is, are we going to decide these issues by a show of hands and say, okay, 51% of the people on the planet, or politicians or whatever countries, believe in global warming, 49 do not. So what should we do? Should we say, well, then global
Well, no.
warming is happening because 51%
Yeah.
voted for it?
or more realistically, if 95% of scientists, whoever the global warming
Mm-hmm.
scientists are, say that it is a thing, but 5%, and they're really smart 5%, right? These guys really know their stuff. You get a really smart guy who says, it's an
It's-
old
it's
guy,
not
and
happening, yeah.
it's actually not happening. Now you got a contradiction. Now you got a problem because you get two really smart scientists. You get 50 million scientists here, and one really smart scientist here. Is this guy wrong? Is he crazy? How many people does it? It's obviously
How
not
many
a show
people
of
does it
hands.
take? How many
I mean,
people
yeah,
does it take
to
for a
make something
theory
true.
to be true?
I mean, we all kind of know. Okay, no matter how many people say 2 + 2 is 5, it's wrong, kind of thing.
Yeah.
No matter how many people say that color is red, even though it's green, it's green.
Right.
But it becomes a problem when we do
vote.
when we vote because
Yeah.
because that's how we do other things. If everyone in a train starts looking in one way, you're gonna be like, oh, what's over there? It's one of those.
And
things
you
where-
look too.
Yeah, and you look too.
Ah,
because
we
it's
caught you.
we got you. Yeah, I've done that in a train where I start just doing this at
And
the
people
roof,
start looking.
and people go like, "What the heck?" I just fucked with them because
No. For you to get the train to look, you gotta go.
Yeah. Everyone goes, what? It's one of those things where we just kind of go with the masses because that's a really good way of staying alive. Everyone starts running. You don't ask. hey, why is everyone running?
Yeah, you run.
You just run just in case.
The lion
You
that's
know, that
coming
kind of thing.
1 block away. You know?
It's democracy it sneaks into physics very very easily. Or hold on. Or in that same vein, if you have a physicist who believes that black holes don't exist, like in the
He's
establishment,
fired. He's fired.
yeah, he can't open his mouth because he gets fired because too many people are saying this. So now he has to tout the party line or face the consequences.
And too many jobs depend on it also.
I mean, that's one of the topics.
Yeah.
No, hold on. The topic, well, whatever. Yeah, ulterior motives in science. That was the one here.
Yeah, number 4, ulterior motives in science.
That was what I wanted to get to with the guy who has a job to keep because
careers.
Yeah, because
funds.
That's really one of the biggest problems in science or anything really, where if you have a charity, for example, and the purpose of the charity is to feed these kids. Now you have the problem because you can't just. Or many things convolute the issue because then many interests get involved that aren't that purpose. So you start stacking up purposes. Okay, but we need money to pay the people who do the jobs. So now you got a separate interest, which is feeding the people who do the job of the charity. And then maybe someone wants to look good, so he joins the cause not to feed the kids but to look good. So he has a different purpose. Yeah. So you get all these ulterior motives in the charity, and the same thing happens in science and politics, everything, where
money makes the wheel, greases the wheel.
Yeah, where really everything only has one pure purpose or one original purpose, and then a stack of shit gets on top of that of purposes. Where with science, if science is just about explaining phenomena, but then now you have a job to keep because you're a physicist in a respected school. Now you have to watch what you say because I mean, even with tenure, you have to watch what you say because you get labeled as a crack. Cool, you're out.
No, and it approaches more what the Vatican does or whatever, just to name one religion, where, if you're going to be a cardinal in the Catholic Church, you had better fall in line with a party line.
Or face the consequences.
Or face you get defrocked.
That's the problem. When there's consequences, when there's things to be lost, now it's like, okay, now we're making it harder.
Yeah, but then you go outside the bounds of science because now it's not an issue of are we going to understand a mechanism or explain something? No, now it's an issue of I better watch for my job. I better watch my tongue. What will my peers think of me?
Yeah, if someone paid me $1 million to push particle physics on this channel, it'd be really hard to say no. It's one of those things where you go,
you'd be proud.
Now a new
and you'd fight against me.
Yeah, no, you get half.
Okay, then I'll go for particles.
But another ulterior motive in science is when I was talking about my friends, where now it's a case of ego or who looks smarter. Now it's not really money or careers, but it's
your religion.
Yes, but it's like it gets into the personal level. It starts hurting and like it starts getting offensive when someone says, "What? You don't believe in black holes?" Or I tell them that what they believe is shit. I mean, that's essentially what you're both saying. You're saying you're an idiot.
Yeah,
I mean that's always the underlying thing.
You're raping his virgin.
Unless you're two really nice guys, it's very hard to just be like, oh, you believe that and I believe this. Oh, that's interesting. Well, let's get to the bottom of it, like diplomatically. It's really really hard to do that. But that's science. That's actual science.
You're saying my God doesn't exist?
Yeah. If you get two robots just talking science, they don't get hurt feelings. They're not talking about money. They're just getting to the bottom of it. Okay. If we wanted to explain magnetism, let's start. What's your explanation? What's mine? Pop, 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 they get to the bottom of it, or what are each other's fallacies. But ulterior motives in science is really a human thing where anytime two people are doing science, the purpose is originally just to explain something. I mean, even when people are debating about God, does God exist? Are we really getting to the bottom of the issue of does God exist? Or are we, I mean, many ad hominem attacks come up where it's like, oh, you're just a philanderer and whatever. Yeah, but that has nothing to do with the issue. Back to the scumbag who can tell the truth thing.
Yeah.
Or
the funds that roll into
or the fund. If you have this huge backing, it's like it makes it really hard to keep a clear head when you have something to lose or something to gain.
And when there are all these other issues that surround which are non-scientific, authority, money, all these things that really get involved into science, it muddies the waters.
It's fun though. That's the problem. I mean, even in this chat, you get a lot of tongue in cheek, jabs at each other because it's kind of a sport. It's kind of fun. But if we were just gonna be like perfectly serious,
right, truly scientific,
then it would be a really boring chat. It'd be a really boring because now we're just talking facts.
But try that with the Pope, or the Pope is now in, or just went yesterday, the day before, went to an Arab country, so he went to the heart of the Muslim world. And I'm sure they're going to have a laugh at the Pope and say, look what this guy believes in, and it's going to be vice versa, The Pope is going to say, and these people believe in all this nonsense, and here they're going to be fighting, and, each one has his religion,
People go to war over their beliefs.
Yeah.
It's
a fact. That's a fact.
That's a fact. That's a fact, Jack.
Okay, so let's see. What do we have?
Failure of the imagination and its consequences. Best theory we've got, so we have to run with it. Yeah. This is another issue that I've run into in the Patreon with my dad.
The best theory?
Where if you don't have the rope theory, right? Or if you don't have whatever theory you believe in that isn't mainstream, like electric universe or flat earth or whatever you want to, if you have an explanation that isn't mainstream, you kind of get annoyed with the mainstream but at the same time, it's the best the mainstream has. If the only explanation you have for something, you just get one explanation, then you kind of have to run with it. It's one of those things. Or also with the authority issue, where if the best people, the best, brightest minds that we have explained physics in this way, then if that's the best we got, that's kind of what we got to run with. You don't consider alternatives, or maybe you don't have alternatives. It becomes this. It's like you're choosing from a pool of wrong answers. That's the problem.
Yeah.
You only have wrong answers at your disposal, so you just have to go, oh, this is the best we got. Well, it has a lot of problems, but it's the best we got. So whatever problems it has, that's just the weirdness of the universe.
But that's why science has to be open. In that sense, there should be no censorship in science. You can have that in politics, in religion, whatever you want, but in science, there's really no room for censorship. Really, there shouldn't be.
But
because we should all hear all the theories out there, and everybody picks the one he wants. I don't care. I'd rather. I'm not an electric universe guy, but I'll kill for their right to be heard. That's what I mean.
Yeah, but it's really hard not to censor, because if someone comes in and has just such a weird, like if someone comes in, it's almost like he's wasting everyone's time. It's on that level where someone comes in, it's like, just get out of here.
I'd rather have the flat earthers in the conference room and not have them outside. I really prefer them in the conference room. I'll hear them, give them their 5 minutes worth at the microphone, say, okay, guys, we heard you, thank you. But if you don't hear them, you have nothing to compare against. I have no problem with theories that I don't like. I have really no problem with that. But, the censorship in science is a bad deal for all of us.
Yeah, you can tell this list isn't complete.
Yeah. We're still brainstorming. By the way, if anyone has more things to add to this list, please go ahead and we'd like to hear that.
Failure of the imagination. That also goes to the guy earlier who said the star is going around nothing. It's a black hole. What else could it be?
Yeah.
That is by definition a failure of the imagination. He can't think of another or better, a less plot holey explanation for the phenomena.
Gensel, that's his name, Gensel.
Physics is a boring subject because nobody understands it and it doesn't affect lives. Yeah, classical versus modern physics, where with classical physics, everyone kind of understands it because it's day to day. If I push this bottle, you can kind of calculate and kind of figure out, okay, why did it fall and that kind of thing. But with modern physics, it's so far outside of our day to day, and it's explaining things that has nothing to do with us, and there's no way to verify. I mean, the forms of verification are very convoluted, So it's very easy to kind of trick yourself into things that aren't there and that kind of thing.
Well, what you're verifying is really the description. Yeah, I let go of the pen. Yes, it fell to the floor. I verified what the guy in China told
yeah,
me.
but you're not verifying
But you're
the
not,
particles.
no, what you're not, what you cannot verify is the theory. There is no verification for theories.
But when you say it like that, it's really hard to. I mean, the one that we always talk about is dropping the pen, where
Yeah.
this is the explanation. That's the experiment.
Yeah, that's
now there's a zillion and one explanations for that.
Right.
And you can't do any other experiments. That's
And
it.
the issue is that, yeah, you drop the pen, you let go of the pen falls to the floor. Now we have to explain.
Well, that's not true.
So you have 3 or 4 explanations.
It's a little more complicated than the pen falling to the earth, because it's like you have to collect clues. Because it's not just the pen. You also say, okay, but the earth and the moon also have this thing going on. It seems to be the same phenomena. So you kind of stack clues for a thing, and then you explain it.
Yeah, but my point is, 5 guys come to the conference. Each one gives his explanation. Let's assume those 5 are different, okay? 5 explanations for how the mechanism of how the pen fell to the floor, okay? So this guy says particles, the other guy says waves, the other guy says warp space, and I say ropes, right? So we come up with all these theories, these explanations. We can't prove any of them.
Yeah.
There is no such thing as proof for a theory.
There's no way of
all
knowing.
all we have is mechanism. This is my mechanism. This is his mechanism. What you believe, what you take home with you, that's your personal belief. That's your personal religion.
But let's at
But
least
the explanation has to be objective, right? Objective, and there is no possibility of proof of a theory.
You can't see gravity.
You can't see the invisible. All you can do is mimic
You
it.
can get clues.
Simulate it and say, look, this is how I would do it if I were Mother Nature. That's all you can do.
Back
Stamp
to
collecting.
no, hold on. But physics is a boring subject. It becomes boring. I see this a lot when I watch, like, for example, Joe Rogan's podcast or Sam Harris's podcast, or anyone who's trying to interview or any interview about any physicist, when they ask Richard Feynman how magnetism works, where if the person starts just spouting a whole bunch of fancy words and by that I specifically mean words that the other person the interviewer doesn't understand, he's doing the guy a disservice. It becomes very boring to listen to, because he's not making any sense. He has no train to follow along. It's like telling a story and you just start messing with the characters and the thing is that you can't follow along anymore. So you stop listening at some point. The soldier goes up to the dragon and then a meteor hits the planet Zunon, and whoa, what the heck does that have to do with the soldier that went to kill the dragon? It's like that kind of issue where when the other person starts speaking in a language you don't understand, or using metaphors that you can't piece together with other metaphors, and when you get lost in the conversation, most people don't do physics. Most people don't do physics because you can't listen to it.
You saw it in Joe Rogan's interview of who was this guy? Brian Cox the other day. We were looking at that for a little while, and Joe Rogan said, I don't understand anything that you're saying. But he spent 2 hours. He said that at the beginning almost, like 10, 20 minutes into his discussion. They lasted 2 hours listening to this guy just babble about nonsense that nobody understands. And he's just, okay. And
you don't know where to start.
It's like nobody understands any of that stuff. And that's why physics or the mathematical physicists, as I say, have converted physics into a boring subject, because nobody understands anything anymore.
Into a boring religion.
They say you got to take a course in math to understand what we're saying. And, all I want is a mechanism. I need to know how you did the trick of cutting the lady in half. I don't want an inscription saying I did it with so many strokes of the saw in 10 seconds. I don't care about that. I want to know the mechanism, how you did the trick. And that's what they never come up with, because whenever they do, it's always irrational. Oh, and they'll add that, by the way, we don't understand this either.
Stamp collecting. Don't get to the bottom thing. Yeah, they're piling more and more. Yes, the stamp collecting issue is mainly in relation to the particles, where they're not what was it? The list of particles that they have: gluons, muons.
Oh, yeah.
It has like 100 and
There's
God
no,
knows
there's
how
like
many.
200 particles
200
that
particles.
of different kinds that they've invented, names that they have invented, and it's become more and more complex.
But why? When they try to explain, I don't know, light,
Yeah.
or what a particle is made, what an atom is made out of. They take a hydrogen atom, and then they crash it into another atom, or really
Yeah,
they
yeah.
do it with gold
Yeah,
atoms,
yeah,
right?
they smash them. Yeah,
They smash
do it
two
with them.
atoms.
Yeah.
To see what the atom is made out of, and then they name each one of the
Little circles.
strokes that comes out.
Yeah, this is
At what
Charlie and
angle?
this is Johnny.
So they're not really explaining what's in the atom or how
And
these
Adam
two
works.
how an atom works.
Yeah.
They're just naming each part of the atom. It's like naming each part of the cow. We don't know how the intestines work, but this is Johnny, this is Bobby, this is Sally,
Yeah,
this is
yeah.
the gluon, this is a muon,
Yeah.
and this does that.
Which are descriptions.
You start getting this list of particles. They're not getting to the bottom of anything. They're really just getting to the top.
No, and what you have to understand is you cannot cut. Let's take a stone, just anything. We'll take a stone. We'll cut it in half. We'll do the Democritus thing. We say we can't get to the end of cutting, and never arrive at anything. If you cut something in half, you're always going to get something left over. Mm-hmm. And so quantum mechanics, at least, right, within mathematical physics, quantum mechanics predicts, to use their word, predicts an underlying particle that forms everything in the universe. It predicts. You can't cut that particle in half and end up with nothing. And I'm sure you can only go so far cutting in half, mentally or otherwise, using God's knife. And at some point you have to say, okay, this is the particle that makes up everything else. And the reporter cannot come over and say,
what's it made of?
What's it made of?
I can't cut it anymore.
What am I going to say? Give me more money, I'll make a bigger atom smasher and see what it's made out of.
That's the difference with the way
it's a conceptual
the way
issue.
Pops does the physics, where he starts at the bottom. Okay, let's assume we have a thing that cannot be cut. Right. What's the bottom? What's the very cut? What's the smallest thing that
that's
makes
your
everything
elementary entity?
And the way modern physics or particle physics is done, they do it the other way around. They take a hydrogen atom, they cut it in half. What's this? What's the muon made of? What's the gluon made of? What's the gluon made of? And they just keep cutting and cutting. Instead of just starting,
you've invented 3 more particles. I'm going to put them on the list.
3 new Nobel prizes for me.
Yeah,
and Nobel prizes
the
also
gluon, the muon, the QAnon.
Oh, that's it for that. And number
2. Put number 2 again.
No,
that was
physics is absolutely literal.
Okay, that's for that's in other words, literal in the sense of objects, right?
Oh man, yeah, physics being literal. That's one that I've.
Yeah, you can't say in physics. You can't say in physics. Love moves mountains. That's literal. So you can say that in poetry, but you can't bring that into science or physics specifically and say love moved the mountain. You can't do that in physics because physics is literal. And if you're going to move the mountain, a physical object, with love, a concept, we got a serious problem. So you can't use that kind of analogy, or you can't use that type of language in physics. In physics, you got to use objects, and in that sense, physics is literal.
But it's almost too literal.
Yeah,
where it's really tiring to stay so much, because many times even while we're doing the channel, we talk in analogy and metaphor, but really just to kind of understand just a bit of it.
Yeah.
But staying literal. I mean, I've had situations where we'll be discussing something in the kitchen, trying to get to the bottom of something, and in my head at least, I'll have been using a metaphor or like an approximation, like a vague area of something, without even noticing it, and that's kind of the point of a discussion where you're trying to flesh out each other's vaguities.
Yeah.
What parts haven't you precisely gotten to the bottom of? Because. Any room for error is one of those Murphy Law issues where any room for error, that's where the weeds will grow. You're gonna have some misconception or some misunderstanding if you haven't defined everything precisely and been rigorously scientific with it. And with physics being perfectly literal or absolutely literal, it gets really hard because I mean
You can't use the
I
words of ordinary speech.
yeah, I think it's
bring
just
them in, without
because they
indiscriminate.
fall apart real quick when you get to the nitty gritty. When you
Yeah.
keep going deeper and deeper, what would be a good example for this?
Well, anyways, it's essentially that's it. You can't bring words of ordinary speech indiscriminately into physics. You really have to be careful with your language because language does play a significant role in science. I mean, if you're going to explain something to someone, you had better have your language correct. You better know what each important word in your dissertation is going to be, and then only then can someone understand what you're trying to convey to them. But you say, well, mass,
for
and then you say,
example-
well, I don't know what mass
Yeah,
is, but let me
like-
explain it with
Like
mass.
black hole, for example.
Yeah, it's all mass.
If you,
What is that?
If you have a black hole, or someone says, yeah, there's a black hole there, that's what's making this go around. I mean, there you have your demonstration. Your experiment is you have nothingness, and you have a planet going around nothingness. That's the
black hole,
That's
yeah.
the show. That's the
Yeah,
that's the explanation.
that's
now
the magic
No,
trick.
sorry,
That's the magic trick.
Sorry. That's the experiment. Basically,
Oh, yeah, the
And now
magic
you have
trick.
now you have to explain it.
Yeah.
And now you say, oh, a black hole is there. Okay, what's a black hole?
All mass.
Literally.
All mass, no volume,
All
no
mass.
matter.
Okay, but now what's mass and volume? Literally.
Yeah, and then we
now
say,
you-
well, we don't know what mass is, but let me describe it to you. Here's the equation. What have we learned? What progress have we made? Anyways, we ran over time today. We usually go 1 hour. Today we went about an hour and a half. That gives you an overall idea. The point of this lecture here today,
All the things that get in the way of
these are
physics.
peripheral things that are there in the background, which always come into any discussion of physics. Almost always, one of these things that we mentioned today, one of these on the list, will come in and cause trouble because not all of us see the same issues in the same way. And I'm not talking about physics. I'm talking about all these peripheral issues. I mean, someone doesn't know the difference between an explanation and a description, between belief and knowledge, between proof and what would
Persuasion.
be yeah,
Which is really the same
right,
thing.
person, yeah, essentially the same thing. Then these things come in there. They do cause trouble in the debate, in the discussion, in the dissertation. And these things are always in the background.
And it's
We
a lot of
can't get rid
human.
them.
It's a lot of human
Human
error.
yeah.
It's a human error issue where
Yeah. Should
I
we
mean,
vote for
they,
theories?
I think they made a list of like 25 different types of biases that you can kind of get bogged down into when you're trying to believe something or trying to make a decision. There's 25 different ways that you can get something wrong. For example, just one of them was I think a price difference where if you have a bottle of wine that's 500 or let's say $50, and to sell that you put a more expensive one next to it just so they buy the cheaper one. And it's one of those. It's like, oh, now this $50 looks cheap in comparison to this other one. If you just leave the 50, then it's an expensive bottle of wine.
Right.
And it's those kind of things where it's like our brain has these like ancient monkey ways of doing things that just get in the way of the robotic, logical, getting to the bottom of something.
Yeah.
And it's just a huge pile of shit that just gets on top, that just muddies the water. It's really hard to see anything because you can get bogged down in this issue or that issue without even knowing it. But if you have this list, or I mean, I'm sure people can make a bit better list than I did. If you have all the biases of physics, for example, then you'd be like, oh man, I might be doing this one. Let's make sure I'm not doing this fallacy or that one.
We should at least be
track.
aware of
Yeah,
all these things. Is voting part of science? Do we vote for theories? Is that science or is
more
that
specifically,
religion?
what?
Or is
Or maybe we're doing a voting without knowing it kind of thing, where it's like, oh man, wait, I only believe this guy because he's got a medal.
authority.
And so you
yeah.
don't even think about these things. Sometimes
Yeah.
you'll just be listening to something. Oh man, this guy sounds smart. So you try to interpret what he said. You try to make sense out of what he said, but he might just be babbling for all you.
Yeah, and you believe in him simply because he's got a
And
degree or because he's got authority, he's got a Nobel Prize, and that gives him the authority to speak to you. And then it takes us back to the Stone Age, almost, I would say, to the Dark Ages, where, the priest, he was the guy who could read, and the rest of the people who came to his mass, they didn't know how to read, so they had to rely on him. And that's more or less what we have today. We have the mathematicians, you know, they take all these math courses up there in the high level area, and then they come to talk to you in math terms. You say, well, I don't understand. You know, I'll just believe you because you got a degree. You know,
Yeah, but I think
and
a
the
lot
guy
of
can say
this-
anything almost.
But I think a lot of this monkey brain thing is really a form of conservation of time and energy, where instead of trying to get to the bottom of it yourself,
That's when we should.
you just don't have time to do it. You just say, okay, this guy's smart. Let's just go with his.
I'll just
You
accept
don't-
whatever he says.
Yeah, you don't have time to or interest or energy. Like you have bills to pay, you have things to do. You just want to know how a magnet works. The guy says north attracts south. Well, if that's all we got, I guess that's the end. That closes that chapter. On to the next one.
Or you do like what we did the other day. We watched the movie, this is Interstellar, and we found out how general relativity works, right? We're just watching the movie, and oh, okay, I got all the documentary that I need from general relativity by watching that movie.
Yeah,
it's all condensed in
It's,
there in
it's
that
kind
story.
of it's kind of like people who watch the Daily Show to get their news.
Yeah, they're
where
shot in the arm.
they like the comedy with the news.
Like
it's
the
more
headlines.
palpable. It's more
just like the
palpable.
headlines.
No,
and
no, no,
I don't have time
no.
for the.
With the Daily Show, it's more palpable because it's like they give you the information with sugar, with comedy,
okay.
and the same thing with the movie where they give you the science with the show, with Matthew
Right.
McConaughey. doing this cool
And the
stuff
flashy
with the-
scenes.
So
Yeah.
it's more palpable. But it's really hard to do science. It's really hard to do physics.
Okay, anyways, keep these things in mind, and if you want to contribute to the list, obviously we'd love it. Just even if you put something that we don't like, we like it anyways because the
We
list should
consider it.
expand. Yeah, things that get involved in physics explanation, which don't pertain specifically to physics, but are always out there in the background, and they cause trouble because we all have different notions of these things, you know, and they do interfere with understanding sometimes or with how we think physics should be. With that, we'll see you next time, same station. Okay? Bye-bye. We'll see you then. Bye-bye.